Hello, gentlemen. Welcome to week 4. I hope everybody enjoyed a few days off and everybody did well on their exams and the third problem set. You should be checking your grades online, and remember that if you want to just switch to a preview class, now is the time to do that. Otherwise, this is going to be a grade that it's going to go on your transcript. Okay, so if you're struggling and you have some questions about that, please make sure to touch base with me so we can move forward in the appropriate manner. All right, let's move on. We're going to continue our study of trig. We're going to do some right triangle trig, and hopefully you guys remember some of this SOHCAHTOA and understand the different rules. But let's get underway. Let's label our different sides. So if I'm looking at this triangle, I have an angle theta. This is going to be defined as my adjacent side. That's my opposite side, my hypotenuse. And again, I can relate those with the Pythagorean theorem. Okay. Let me get my pen going here. Hopefully we have no pen malfunctions here. We know that we have c squared is equal to a squared plus b squared, where this would be side A, B, and C. All right, so we already know that. So we have an angle between 0 and pi over 2. Let's put some definitions out there. The sine of theta is equal to the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. Cosecant is hypotenuse over opposite, or 1 over sine, and we already knew the 1 over sine part of it. Secant is hypotenuse over adjacent, or 1 over cosine. Cotan is adjacent over opposite. Tan is opposite over adjacent. And we have cotan is 1 over tan. You can see that these two are just inverses of each other. Okay? You guys should know that. Let's do a little bit of practice here. There are my three sides. So again, this is my, down here would be, on 6 would be my adjacent side. And this would be my opposite side over here. Let's look at the 6 different trig functions. So sine theta is going to be opposite over adjacent, which should be 8 over 10, I'm sorry. Opposite over hypotenuse, it should be 8 over 10, or 4/5. Cosine is adjacent over hypotenuse, or 6 over 10. We'll reduce that to 3 over 5. Cosecant is hypotenuse over opposite, so that should be 10 over 8, or 5 over 4. And look, if you note from before, this is equal to 1 over sine of theta. Okay. Secant is hypotenuse over adjacent, which is 10 over 6, which is equal to 5 over 3. And this one here is 1 over cosine. Okay, so you should recognize those as we're going through. Get rid of those. Then we want to look at tangent. Tangent of theta is opposite over adjacent, which is 8 over 6, or 4/3. And cotangent is adjacent over opposite, 6 over 8, 3/4. Okay? Let's do it for this other angle, alpha, and we're going to see a relationship between some of these functions, these sines and cosine functions that are going to be important. Let's look at the sine of alpha. Sine of alpha, if we're looking at an alpha, now this is my opposite side, and this is my adjacent side, and this is still my hypotenuse. But for sine of alpha, I have opposite over hypotenuse, which is equal to 6 over 10, which again I can reduce down to 3 over 5. What I want you to note here is that the sine of this angle is actually equal to, whoop, let me just finish this up. Here's the cosine of alpha, it's 4/5. But if you look here, and let's go back and look at cosine of this angle, remember cosine is adjacent over hypotenuse, so the cosine of theta here, adjacent side is 6 over 10. And over here, sine is 8 over 10. So I'm making this note here, and what that actually tells me is that cofunctions, and sine and cosine are cofunctions of complementary angles. Remember, complementary angles add up to 90 degrees. Okay? Or pi over 2. And so what I'm learning here is sine of 90 minus theta is equal to cosine of theta, and cosine of 90 minus theta is equal to sine of theta. Okay? And remember, for a right triangle, the sum of the three angles is equal to 180. And so that's how we can relate these. Okay? Hopefully you guys, make sure you guys understand this. So I can say that the sine of 40 is equal to the cosine of 50. Or the cosine of 30 equals the sine of 60. And you guys should already know that because this is root 3 over 2 for both sides. Okay? This is an important concept to make sure you guys understand that. Let's see if it works for cosecant and secant. Cosecant is hypotenuse over opposite, which is 10 over 6, which is 5 over 3. Secant is hypotenuse over adjacent, so that's going to be 10 over 8, which is 5 over 4. And if you look at that, if you look at a secant of theta now, secant of theta is hypotenuse, which is 10 over adjacent, but for theta that's going to be 6. It's the same thing. Cosecant of theta is hypotenuse, which is 10, over opposite, now again we're looking at theta, which is 8. So again, we're seeing the same thing. So the cofunctions here, cofunctions of complementary angles are equal. So I can say that the cosecant of 40, cosecant of 40 equals the secant of 50. Okay? And I can do it for any angles that are complementary. Okay? Let's do it for tangent and cotangent. Tangent of alpha, tangent is opposite over adjacent. So I have 6 over 8, 3/4. Cotangent of alpha is adjacent over opposite, so it's 8 over 6. And I'm going to note that that's cotangent. Tangent of alpha is cotangent of theta. So let's look at cotangent of theta. Cotangent of theta is adjacent, which now for theta it's 6 over 8. And tangent of theta is opposite over adjacent, which is 8 over 6. So I'm getting the same thing. Again, again, the cofunctions of complementary angles are equal. Again, I'll write it out. Tangent of 40 equals cotangent of 50. All right, it can be any angles. It could be 30 and 60, any complementary angles. Okay, make sure you guys understand that. That's important. Let's look at. I want to look at two specific triangles. Here's a right triangle, 45, 45, 90. Okay, if I label that side as 1, that means that this side is 1 because I have an isosceles triangle. Okay, and that would be hypotenuse of root 2 because I would do 1 squared plus 1 squared equals c squared, so c is equal to square root of 2. And if I'm looking at the sine of 45, I got opposite over hypotenuse, which would be 1 over root 2 or root 2 over 2, right? Which is the sine of 45, sine of pi over 4, same idea. Cosine of 45 is going to be 1 over root 2 as well, root 2 over 2. Cosecant is going to be root 2 over 1, again 1 over sine. Secant, same idea, 1 over cosine. It's going to be 1, and cotangent is going to be 1. So this is a special function here. Make sure that you guys understand that. Again, I'll write this as 1 over sine. And this is 1 over cosine. I'll put 45. That should be 45 as well. Okay? You guys should know those. This is one of the special triangles. The other special triangles are 30, 60, 90. If I just open this up a little bit, I can make an equilateral triangle here because all the angles would be, if I did this one up here, this would be 30, 30, so I get 60, 60, 60. So if these sides are 1 there, then that has to be 2 there because the total side is 2, 2, and 2. Okay? Make sure you guys understand that. All right, by combining another triangle right on the other side, another 30, 60, 90, I have an equilateral where all the sides are the same. If I do that, I can find the measure of this angle. Again, that angle is going to be, I'm going to use, we'll call it x, so we'll go x squared plus 1 squared is equal to 2 squared, which is 4, so x squared is equal to 4, this is squared, whoops, 2 squared. So that's going to be 4 minus 1, which is 3, so that we should get as radical 3 for that side. Okay? Again, I can look at the sine of that angle. Opposite, sine of 60 is opposite over hypotenuse, so root 3 over 2. Cosine of 60 is going to be 1/2. Cosecant is going to be 1 over sine, or hypotenuse over opposite, which is 2 over root 3. We want to rewrite that as 2 root 3 over 3. Secant of 60 is simply going to be 2. Tangent is going to be equal to root 3. And cotangent is going to be equal to root 3 over 3. Okay, again, these are special angles. You should already know what the sine of 60 is, and you should know what the cosine of 60 is. 60 is pi over 3, so you've already memorized these, but they're helpful to just revisit. Let's do it with the angle of 30, another angle that we want to make sure we understand. So sine of 30 is equal to 1/2. And also just make a note here, if you go back to the last slide, that this was equal to the cosine of 60. Okay? And again, that's because the cofunctions of complementary angles are equal. I got root 3 over 2, which again, if I look at this, I could say this was equal to the sine of 60. I could write these out for every one. I'm not going to, but you guys should see that. Cosecant of 30 is hypotenuse over opposite, so I get 2. The secant of 30 is hypotenuse over adjacent, so I get 2 over root 3. I got to get rid of that radical on the bottom, so it's 2 root 3 over 3. Tangent of 30 is opposite over adjacent. Just going to give me root 3 over 3. And finally, cotangent of 30 is going to be adjacent over opposite, which is just going to be root 3. Okay? All right, here's some practice, fellas. This is going to show you, this example is pretty good of a right angle trig. I know there seems like a lot of problems here. A lot of them are pretty straightforward. Some of them are just doing some stuff on your calculator. But make sure you understand this. Make sure you get this whole idea of right triangle trig down. It's very, very important. You guys should know SOHCAHTOA already. And the other thing I would make sure you understand is that cofunctions of complementary angles are equal. Okay? Do these practice. Email me if you have any questions. And welcome to week 4.